Okay, we're back on. All right, so now we need to calculate how long the ball was in the air. Okay, so we know how to do that, right? We've got that equation. So to calculate how long the ball was in the air, we look strictly here at this in the y direction because we're just looking at how it went up and it came back down. All right, it actually followed a flight like this for the most part. Actually, followed a flight probably like this, more than likely. That's really the flight, but we're calculating as if it went like this, right? So notice the y part big here, not so big, not so big, not so big. Zero here at the maximum height, and then the y starts going like this and getting bigger and bigger as it goes down like that. So this is what the y velocity vectors look like during its flight. Okay, that's what the y, um, and then they equal zero up here at the top. So that's all we need to find the time, because we know that the time is equal to 2 times v naught y, which you found here, or vy in that direction, divided by g. And we did that in mini lesson 3. So you can find the time. And then the next thing they ask you to do, the next thing we want you to do is find the range. And what I say is a physics 210 student there. Don't be confused by that. I'm just saying this is the type of problem. If I gave this problem to a 210 student on a test, they would give me the schoolhouse answer. And they'd go, well, since I got the time here, since this is known, then the range that it went, the distance that it went, would equal v naught x, this guy. Like, I should probably put my knots in here because that's the initial velocity that they went off. V naught x times time. That gives me the range. So you compute the time here, then you answer the next question there. Now it starts to get a little bit more tricky. Okay, as we go on with the test here. All right, so let's take a look at what else we got here. Convert your answer to feet. Okay, so this range, remember that range is going to give you the answer in feet. Convert it to feet. Now the actual distance was 350 feet. So to do the Reynolds factor, which as I've been studying this drag thing much more, the Reynolds factor is huge, and it's got all kinds of different variables that play with it. But for the most part, what we're doing is the Reynolds factor is equal to the distance that it actually went divided by the distance that you computed. So so the Reynolds factor would be your answer in 12 in would be this 350 divided by your answer in 12. Okay. All right. So now the commentator for Fox Sports retired. And I like John Smoltz. I like the way he calls the game, and was amazed that Pig hit the home run while holding the bat with only one hand. In other words, his right hand, I think he's right. Yeah, he's a right-handed batter. His right hand came off of it, and he just kind of guided the ball down the left field line with his left hand. It looked like he had a backhanded tennis, but actually he didn't. He had a full swing, and then by the time the ball hit the bat, his right hand was off the ball. Um, the answer is the middle one. I'll just tell you. Okay. All right, but watch the video. It's kind of cool of Tommy Frazier's no-handed home run and of Fueg's home run. Those are the only two videos I have there, and each of them are 3 minutes long, so it's not that big a deal. All right, so now we're gonna have Shaq shoot some free throws. My boy Shaq. I just like Shaq. He's got his master's degree. He's written several children's books. The guy's just amazing. But he couldn't shoot free throws. All right, so now what's the optimum he wants to shoot free throws? Oh, maybe. I don't know. Anyway, so now this is the one that got hard. All right, so here's what I'm figuring. We're going to have him launch the ball at 53 degrees, which is the optimum angle. So you probably can figure out why I picked that answer right there. Okay. Before returning to launch, okay, so, and then we got this formula because remember from mini lesson 11, what we did, or 12, from mini lesson 12, we took, we had two equations and two unknowns. So we came up with an equation that we didn't know and substituted that in for for another one of the unknowns in the other equation, and so that's how we got it. So now, all right, so now we've got to find out what V naught squared is. So we've got this funky formula here of 2V naught squared. I'll show you my work here in a minute. Times the sine of 2 theta, it's that old double angle formula, divided by G is equal to the range, okay? And the range of 4.8 meters is 15.5 feet, okay, in meters. All right, so this is what we've got now. How the heck? So this equals 4.8. Now, as a physics person, I like to do everything. Now, the nice thing is we know that the angle is 53. So 2 theta, you can just put in the 106. All right, there you go. That'll help. All right, but we're trying to get this guy out of there. So I'm going to multiply both sides by G. I get 2V naught squared is equal to, or sine of 106 is equal to 4.8 times G. We got that far. Where we know that G is 9.8 meters per second squared. All right, so we've gotten that far. Now divide by 2 and divide by the sine of 206. So V naught squared, here's a formula. I probably should have just given you this. 2G divided by 2 times the sine of 106. Now, when you're going to do this on your calculator, here's how I would do it. I'd put parentheses 4.8, parentheses 9.8, double parentheses, divided by parentheses 2 times the sine of 106, double parentheses like that. That's the way I would do that. And then when you get that done, you're going to get your answer over here, and then you need to take the square root of it. All right, and that'll give you our initial launch velocity that Shaq had to launch the ball to. Had a nice, pretty free throw. All right. All right. Okay. The ball was launched. Now that you've calculated the initial velocity, use the formula to find the time. So use this formula to find the time. This is just plug in, just plug and chug. Now notice the sign here is not 2 sine. It's back to the 53. So you just plug and chug on that, and you should be good. Okay? All right, have fun with this now. Remember, this is physics. It's fun, damn it. All right, out here, and I'll see you next week.